All right, number 5. Let's solve the system of inequalities by graphing. Good news, both of these two inequalities are already in slope-intercept form. So let's graph each one of these, slope-intercept form style. Let's graph this one. I'll put this one in red. So where do we start? Positive 2. Slope is negative 4, so down 4 units for every one that we go to the right. Notice I'm going to run out of room going this way, and I'll run out of room going the other way, so I think I'm all set to draw that line in there. Now double check. Hey, see how there's a solid line underneath that inequality? Because now we are less than or equal to. So that means we need a solid line here for our boundary. Okay. Now because it is less than or equal to, remember less than or equal to, or even less than, you are always going to shade below the line. And we've talked about that in class. How do I know where below the line would be? It's all about that y-intercept right there. Numbers that are less than that 2 are all these ones here, going right down that line right there. And see what side of the line that's on? We want to shade that side of the line. Okay? So there's this side. Moving on to the next line. Now I need to graph that y is greater than x minus 2. Let's put this in blue. So first thing, we need the y-intercept, which is down here at negative 2. And then isn't that slope just a 1? So we're going up 1 and to the right 1. What do you notice about this inequality? Do you see how that inequality is just greater than, not greater than or equal to? Greater than, instead of greater than or equal to, we need a dashed line there, don't we? So I'll make that dashed. There's that guy. And then if it's greater than, or even greater than or equal to, in both those situations, we will be shading above that line. Focus on the y-intercept. And above that line is everything that is here. Now, how can you properly show me the solution? Remember, that solution is where the two intersecting regions cross. It is your responsibility to do one of two things for me. Either make the solution region a heck of a lot darker than the other two that you shaded. As you can see, I'm making it darker right here. I need to be able to tell that that right there is the solution. That's one way of doing it. Many of you have also just simply only shaded the solution region, which would look something like this. You give me something like that, that works too. Notice that we are below the red line and at the same time above the blue line, and we've put the right boundary lines on those. Okay? So either one of those two ways is a way that we can show that solution, like this or like that. Either one works. Okay, so let's look at solving some of these systems here. Couple things to keep in mind. Like I said before, I'm not too interested in one particular way of solving the system. I'm looking for you to make sure that you know the most efficient way to solve the system. It does not matter which way you go about doing it. Okay, so if I'm looking at trying to solve this system here, looks a little bit dicey here to graphing it, and I can show you why. The top one, if you look at that y right there, I know I'm going to run up with a y-intercept of 7, which wouldn't be that bad. But if you look down here at the bottom one, I'm going to take that 9 and have to divide it by 4. That's going to be a really squirrely looking y-intercept, so I probably don't want to graph this one. I think we could probably easily graph this one with elimination. Substitution, I don't know if I'd want to do too much because that's a negative y going on right there, and that might not be all that fun to graph. I'm sorry, all that fun to solve. So here's what we're going to do instead. Let's go ahead and solve this with elimination. To solve this with elimination, I'm going to go ahead and take this top equation. Let's multiply it by a negative 4. The reason why negative 4 might not be a bad idea is because then we can just simply multiply all these, and that would create a positive 4y right there. So let's go ahead and multiply those together. So we take the negative 4 times the negative 4x, negative 4 times the negative y, and negative 4 times the 7. Go ahead and write it over here on the side. So as you can see right there, just saved a little bit of time of you watching me write all that stuff down. So now we're going to work with this system here. Now this system, we could eliminate the y's pretty easily by just doing addition. So let's add those up. So the 16x plus the 3x, adding those up vertically. See those two guys right there? If we do that, we're going to end up with a 19x. The y's will eliminate, and then negative 28 plus 9, what's that going to put us at? You got it, negative 19. Ooh, I like the way this is going, because then, now to solve, I can just divide both sides by 19, and now x needs to be equal to a negative 1. Okay? Now, I'm only halfway to my correct answer. Remember, I think I've already decided to solve this one with elimination, so I'm not really going to need this graph over here now, am I? So let's get some more room here to work. I have x being negative 1. I have my choice of either one of these two equations to work with here. Let's go ahead and choose the bottom equation. If I take this bottom equation here, which is 3x minus 4y equals 9, I can now replace that x right there with a negative 1. And the rest would say minus 4y equals 9. That would give us negative 3 minus 4y equals 9. Let's add the 3 to both sides. I like where this is going to. So that gives me a negative 4y. A lot of students might forget to copy down that negative. And that would be a 12. Divide both sides by the negative 4. And so then our y would be equal to 12 divided by negative 3. Kaboom. Okay? We have two answers here. Negative 3 for a y and negative 1 for a x. Ladies and gentlemen, don't hesitate whatsoever to check your answer. You got no excuse not to check your answer. Watch how you can easily check it very quickly. Notice how the top equation says negative 4x minus y. That's the left side of that equation that's still highlighted up there. Well, if x is negative 1 and y is negative 3, let's just substitute those numbers in there. So as you can see, I just put in the negative 1 in for x and put the negative 3 in there for y, keeping in mind that that's still subtraction going on right there. Okay, come back here. See how it's minus? And if this really works, we should get 7 when we're done with it. So go ahead and press enter. Hey, look, there's a 7. Let's do the exact same thing for the other equation. So with the other equation down below, we have 3x minus 4y is equal to 9. So 3x minus 4y. So then 3, and wasn't our x still a negative 1? And I forgot the rest already. Minus 4y. And wasn't our y a negative 3? If all goes well, we should get 9. There it is. We've just checked our answer. So take advantage of how quickly it can be to check our work here. No excuse why we can't check it.